All right, let me talk about this problem from Chapter 4, Section 1, number 27. This has to do with conditional probability. Now, to be honest, I had several false starts on this problem and got several wrong approaches. Unfortunately, it's easy to get the right answer with the wrong approach. So you may have done this and got the right answer, but didn't do it right. But it's worth understanding what this problem really involves. All right? So let me read it. In London, half of the days have some rain. The weather forecasters can correct 2/3 of the time. That is, the probability that it rains, given that she has predicted rain, and the probability that it does not rain, given that she has predicted it won't rain, are both equal to 2/3. When rain is forecast, Mr. Pickwick takes his umbrella. When rain is not forecast, he takes it with probably 1/3. Find the probability that Pickwick has no umbrella, given that it rains. Find the probability that he brings his umbrella, given that it doesn't rain. In other words, find out the probability that he does the wrong thing. There are two wrong things he can do. Right? He can bring his umbrella, he can not have his umbrella and get wet, or he can bring his umbrella needlessly. All right? Now, first of all, we need some facts about conditional probabilities of complements, and let me just put that up front here. The probability of A given B is equal to 1 minus the probability of A bar given B. So we're going to need this here, and the way you can see that is you can just do the formulas. The probability of A, oops, sorry. I don't know why I went down there. Let's see if we can get this right. Whoops. Let me move this over. I think you're not seeing this correctly. There we go. Okay. So why is this true? This is true because if I take the probability of A given B is equal to probability of AB over probability of B. Probability of A bar given B equals probability of A bar B given probability B. Now, this means A intersect B, and this means A bar intersect B, just some shorthand. So if I take the sum of these, probability of AB plus probability of A bar B, that's equal to probability, these have a common denominator, right? Probability of AB plus probability of A bar B over probability of B. All right, now, if B is true, either A or A bar is true. These are disjoint events, so this numerator is just P of B over B of P, which is 1. The other way of thinking about this is think about sample space. If I have my whole sample space, if I'm doing conditional probability, I'm looking at the B half and not the B bar half. And then within B, I can have A or A bar. All right. So if I'm just looking at the left-hand side, this probability here is going to be probability of A given B. This probability here is going to be probability of A bar given B. And these two parts make up all of B, but B is my whole sample space. So from this you can also see that the probability of A given B plus probability of A bar given B is equal to 1. All the given B means is that you're restricting the sample space. Right? So let's go on. Now we have three things going on. Rain or no rain, predict rain or no predict rain, umbrella or no umbrella. All right, so we actually have R and R bar. Those are the two events that divide the sample space. PR and PR bar, and U bar. And we're given some information. If you go back and look at the description of the problem gives us this information. The probability of rain, it rains given that rain is predicted as 2/3. Probably it doesn't rain given that rain is not predicted as 2/3. Probability they take umbrella given that there's a prediction of rain is equal to 1. Notice that this probability does not depend on whether or not it rains. Whether it rains or not, this probability is the same. It's only the prediction that determines whether Mr. Pickwick takes his umbrella. Similarly, probability of U given PR bar is 1/3. Again, the umbrella taking only depends on the prediction and not on the actual fact of whether it rains or not. We also know that the probability of rain equals 1/2. All right, so we have all that information. And let's see what we have here. So this gives us, for instance, let me just say that these three events divide the sample space into 8 possibilities, right? For rain or no rain, for each of those 2 possibilities, there are 2 possibilities for predict, and there are 2 possibilities for umbrella. So we can divide the sample space into 8 events, and if we can find the probabilities of those 8 events, we pretty much can find any probability that's needed in this problem. So let's look at one particular event. The probability of R, PR, and U. That's the probability that it rains, rain is predicted, and Mr. Pickwick takes his umbrella. Now, to get the probability that he takes his umbrella, that depends on prediction. But I can write it this way. The probability of U given RP times the probability of RP. This R intersect PR, that's the same thing as RP, right? As I said, that's a shorthand. Right. Now, the probability of U given RP, I can write this as, the probability of R intersect P, I can write it this way. Probability of R given P, R, times the probability of PR. I'm given the probability of R given PR. Unfortunately, I'm not given the probability of PR. All right? So let me repeat that. In this breakup of the probability, I know 2 of the 3. I know the probability of umbrella, given that it rains and the rain is predicted. Remember, it doesn't depend on whether it rains or not. So this probability of U given RPR, that's the same thing as probability of U given PR, because the rain is not going to affect that at all. Okay? Then probability of R given PR, that's what's given up here. However, the probability of PR I don't know. So what is PR? Now, when I redid this problem the first time, I thought, well, since we don't know the probability of PR, we can't get an exact answer. But in fact, we can compute the probability of PR. And we can do that as follows. Let the probability of PR be Q. All right. Now, we can write the probability of R in terms of the probability of PR. All right. Remember, R is that it rains. PR is that he predicts it rains. We know the probability of rain is 1/2. Right? And we can break this up into 2 parts. This is the same type of breakup that I did above, but it's a little bit different. This here is the probability of RP, RPR, and this here is the probability of R, PR bar. I can break the probability of R up into these 2 parts. And of course I can write the probability of R and PR in terms of this conditional probability R given PR. All right, that's the conditional probability equation. Similarly, I can divide probability of R and PR bar as the product of conditional probability times this probability. Now, what about this here? Well, I don't know P of the probability of PR, but I'm saying that that's equal to Q. All right. So this one here I'm known as 2/3, so that's 2/3 times Q. This one here, well, if he doesn't predict rain, the probability that it rains is 1/3. And the probability that he doesn't predict rain, well, that's 1 minus the probability that he predicts rain. Okay, so I actually get an equation for Q. 1/2 is 2/3 Q plus 1/3 times 1 minus Q. All right. Now, if you solve that, you will get Q equals to 1/2, which is the probability of that he predicts rain, and that's also the probability that he doesn't predict rain. Now, unfortunately, you can go through this problem and mistake the probability of PR for the probability of R and get the correct answer. And that's what I did the first time I went through the problem. I had the condition wrong. Instead of R given PR, I was thinking probability of PR given R, which I don't know. And I used the probability of R, which is not correct. I need to use the probability of PR. So I stand corrected by myself that in this problem you have to use the probability of PR because you don't know the probability of PR given R, you know the probability of R given PR. All right? So let's go ahead and compute what we're asked to compute. Let's see if this is going to work here. Oops, it's a little broken. Let's go back and unbreak it. Sometimes that happens. Okay. All right. Now, what they asked for is the probability that he doesn't bring his umbrella, which is U bar, given that it rains. All right. Now remember, the prediction has to factor in. This is the same thing that the probability that he doesn't predict his umbrella, and rain is predicted, and it rains. plus the probability that he doesn't bring his umbrella. Rain is not predicted, and it rains. See, I'm dividing this event, probability of U bar and R, into two parts. If U bar and R are both true, either PR or not PR. So I can write this here. I missed this step here. Let me just put it in so that you have this complete. The step I didn't show here, and, I should put this in for completion, is equal to, let's see, is this going to work? Okay. This is equal to the probability of U bar R divided by the probability of R. All right. So on the top I have probability of U bar R. On the bottom I have probability of R. I know the probability of R is 1/2. And then these here I can further break down into conditional probabilities. This is the probability of U bar PRR. This probability of U bar given PR. Now I could put an R here. I guess I will put an R there. Times the probability of PRR. And this is probability of U bar R, and this is PR bar R, and times this probability. Okay. Now remember that this R does not affect the probability of U bar. So I can take the R out. That knowing R is not going to affect this conditional probability. All right. So I'll take it out from here. So I can say, just say can ignore. Because R is independent of these possibilities. Right? I mean, U bar is independent of R. Okay, so go ahead and write this. So I removed the R here, and then I broke this one up into conditional probabilities. And I know these conditional probabilities, and I know these conditional probabilities over here. And you can read this on the OneNote page. Let me make this smaller so you can see the whole thing. It's probably better to do that. And everything is on one page. All right, so you can see that. Actually, we can do that. I think it's good. All right. All right, so I broke it up as the sum of three probabilities. These probabilities, I know the probability of U bar given PR is 0. Okay. And then the probability of R given PR, well, that's 2/3 because they give us the information. Then the probability of, I'm sorry, well, here this is 0, so I don't even need to compute these two. For the second term, this probability, this first probability here, is probability doesn't bring an umbrella, given that rain is not predicted. That's 2/3 because Mr. Pickwick always does that. That's given to us. And then this one, probably rain given PR bar, that's 1/3 because the prediction was not correct. And then we have probability of PR bar, which is 1/2. Remember, that's what I had to compute, the probability of PR. So here we get 2/9. All right. And then for the other one here, we just need to compute similar probabilities. U given R bar is probability of U R bar given probability of R bar. That's the definition of probability of U R bar. Okay. And let me move it over a little bit. You can't see that. Okay. And then I broke up this top event into 2 again. So we have these 3. Remember, we can either have PR or not PR. So we divide this event up into 2 parts. All right. So this is going to be a probability of U given PR. Sorry. And then I broke up this event R bar PR using the conditional probability. And this one here is going to be PR bar. All right. And then we can do all of these give all of these probabilities. We know the denominator is 1/2. Probability of U given PR. Well, he brings his umbrella. If rain is predicted, that's 1. Probability it doesn't rain, giving you predicts rain, that's 1/3. And the probability that it predicts rain is 1/2. Okay, then plus probability brings his umbrella, given that rain is not predicted, that's 1/3. This probability it doesn't rain, given that it's not predicted rain, so that's 2/3, and then that's 1/2. And let's see if we get the right answer there. So that's going to be 1/6 plus, looks like 1/9 over 1/2, which I think is right. That's 1/3 plus 2/9. So that's 5/9. Okay, I think that's the right answer. All right, so long way for a problem. It's good to think about this one. Think about the pitfalls, how you use conditional probability. All right.